Here we have summarized the step that we did in the previous video of what the synthesis of the compound right here. And this is how you would write it or see it if you were to select from different options. So the idea is always doing that analysis and see what pathway works best and what gives you like the best yield possible. So here we have another synthesis, and here let's see what is the substituents that we have. That's an ethyl group, and we have two nitro groups that are meta to the ethyl groups. So what would happen if I start from benzene and I do a Friedel-Crafts alkylation? Say I have an ethyl, so I'm doing ethyl chloride in aluminum trichloride. If I do that, again, we're doing the pathway analysis. What is that? So I'm going to be installing an ethyl group. And then we see, okay, this group is activating an alkyl group. Alkyl groups, all of them are activating and ortho-para directing. So here and here. But this is not what I want. I can see that the nitro group, two nitro groups are actually meta to the ethyl group. So I cannot start there. Also, I cannot start from doing the nitration. If from this point you did a nitration, you're going to be, there is another problem that we're going to have. Let's see that we do this. If we do one first nitration, then we can install one. Let's say that we have an excess force in that conditions that is deactivating, and yes, it will direct meta. So I'm going to be able to install the second nitro group where we want. So another nitration. And yes, we're getting the two nitro groups meta to each other as we have in our target molecule here. But what happens, I need to install an ethyl group. And to do that, I will need to do a Friedel-Crafts. And that's not going to work because the ring is too deactivated. So this doesn't work. Friedel-Crafts doesn't work when we have rings that are too deactivated. This is too, even one nitro group is bad enough. So too deactivated. This path doesn't work. So neither this two, this is going to give me the wrong orientation. This is not going to work at the end. So what do we do then? So the strategy here would be, we're going to install first another deactivating group in that deactivating group so that we can have the nitration. Instead of doing a Friedel-Crafts alkylation, I'm going to do the Friedel-Crafts acylation. So, and now I'm going to be installing that. Now this group is deactivating. So this is deactivating and deactivating and meta directing. And now I can do the nitration step. So when I do the nitration here, say that I'm going to have excess, I'm going to do the nitration. And of course, since this is deactivating and meta directing, I can install the nitro group here or here. Either way is the same. Say that you install one and same reaction vessel, you will be having the second group installed. So just with nitric acid, sulfuric acid. So what we did here is, again, we did the analysis. Alkylation did not work at the beginning. So, but once I have, I just need to do another step. Notice that here, that's not my final product. This is an acyl group, so I need to reduce that. But I do have the right orientation of the group meta to each other. So the last step here would be the reduction. And here we can do Clemenson, zinc, mercury, and that's HCl. Or let's do this hydrogen, and we can do palladium with carbon. That's another condition that can give you the reduction. So here you will have the ethyl group and nitro here. So again, always do your analysis of the possible pathway, and you need to select the pathway that gives you the right orientation. And if more than one path give you the right orientation, then select the one that gives you the best yield. So more likely, more less steps or more reactive intermediate products. Okay.